Hello everybody! For today's video, we are going to talk and discuss the ocean waters. At this time, we are going to dive, sail, and explore the depth of the ocean to discover what is in the ocean, how it was formed, and how scientists began the discovery of ocean waters. So, if you want to know about these things, of course, stay tuned and don't blink. Hi there learners! Welcome back to Earth Science. I am Najib Pinotti and we are going to discuss to you with my co-reporters about the ocean waters. But before that, let us first enlighten ourselves about these ocean waters, how these things started. Do you know that in 1992, a cargo ship carrying bath toys got caught in a storm? Shipping containers washed overboard and the weight swept 28,000 of rubber ducks and other toys into the North Pacific. But they didn't stick together. Quite the opposite. The ducks have washed up all over the world, whereas the other rubber ducks are found in the South, in Alaska, in the USA, in Australia, and in more places all over the world. And researchers have used their time to chart a better understanding of ocean currents. Ocean currents are driven by a range of sources: the wind, the tides, and the changes in water density and the rotation of the Earth. So, by the end of this chapter, you should be able to place oceanography discovery in the context of human history, explain where the ocean's water and salt come from, how sea level varies, and discuss how the salinity, temperature, and density of ocean's water change with location and depth, and how this variation distinct to form. And of course, you should also be able to explain what surface currents are and how their configuration relates to it, the Coriolis force, and pressure variations. You should also be able to discuss why waves form, how they behave, and how big they can get. And of course, the last one is you should also be able to distinguish among oceanic zones based on water depths and on proximity to land, and explain how these zones affect life in the ocean. So these are the lessons that you are expected to learn. Without further ado, let's start the discussion. Hello everyone, again I am Najib Pinotti and I am the first reporter, and I'm going to discuss to you the page 511 to 518 chapter 15 of the Earth Science book. And the first lesson that we are going to tackle is all about the discovering the sea. So let's start the discussion. Actually, no one knows when the first person sailed over the horizons, but archaeological evidence suggests that as early as 3000 before Common Era, Polynesians built canoes in which it used to travel among isolated islands in Western Pacific. And the end of the Middle Ages saw the beginnings of modern ocean exploration. Okay, as what you see on the screen, the first picture is Admiral Qing Hu of China. He is the one who explored the Pacific and Indian Ocean between 1405 and 1433 Common Era. And Christopher Columbus' journey across the Atlantic in 1492, followed by the discovery of sea routes to China in 1498. So by that, when the routes to China has been discovered, Then the European Age of Discovery had started in 1498. Hence, a quarter century later, the sole of surviving ship of Ferdinand Magellan's fleet became the first known vessel entirely around the globe. So, as what you see the picture here, it was Ferdinand Magellan. Okay. So, let us see the pictures on the screen. The first picture that you see is China's fleet of large ships set sail in 1405, almost 90 years before Columbus crossed the Atlantic. So it's quiet, it's pretty good. And the second picture is the 1958 map by Abraham Ortelius, a Dutch cartographer, showing the coastlines as they were known at the same time. The third picture is a 19th century chronometer. Then a chronometer is a marine chronometer, is a precision timepiece that is carried on a ship and employed in the determination of ship's position by celestial navigation. So next is the research vessels that are used in studying the oceans. So the first picture that you see is a HMS Challenger. It was the first dedicated research vessel, set sail in 1872. So this is the very first dedicated research vessels that used in ocean discovery. Then the next picture is a modern oceanographic research vessel. And the third is a submersible used spotlight to see at depth. It is used under the water. And the fourth one is a robotic submersible provide information without risking lives. And the last one is a CSAT or a NASA satellite designed to monitor the world's ocean. So guys, these are the research vessels that are used in oceans discovery. So let's proceed to the next lesson. Okay, the next that we are going to tackle is the map of the modern ocean. Oceans covers 70.8% of the Earth's surface and contain about 1.3 billion cubic kilometers of water. And as what is stated, geographers divide the global ocean into 5 separate large bodies. And these are the Atlantic Ocean, Pacific Ocean, Indian, Arctic Ocean, and Southern Oceans outlined by continents. The equator also divides the Atlantic and Pacific into northern and southern portions. In addition, geographers recognize several seas such as Mediterranean, Black and Red Sea, Caribbean seas, bays such as Hudson Bay, gulfs such as Gulf of Mexico, and these are the smaller regions of seawater that are partially surrounded by land. A few seas such as the Dead Sea and Caspian Sea are actually lakes, in that they are completely surrounded by land. Of course, the shapes and positions of today's oceans and seas differs markedly from the way they appeared in the past and the way they will be in the future because of the plate motions. So, this is the map of the modern ocean. Next is the sea level and sea level change. Sea level refers to the elevation of the boundary between ocean water and the air above. When we use the term sea level, we are actually talking about the mean sea level, the average height of this boundary over the course of a year. And at any given moment, the sea surface at a given locality may be higher or lower than mean sea level because of passing waves or the rise or full of tides. The geologic record indicates that liquid water has filled the oceans at least the beginning of the Archean, except perhaps for snowball Earth episodes in the Proterozoic, when the sea surface was frozen and that the overall volume of surface water on the Earth has stayed roughly constant. But because of ice ages, which transfer large volumes of water into glaciers on land, and because of changes in the capacity of ocean basins, resulting from changes in the volume of mid-ocean ridges, sea level has gone up and down on the order of tens to a few hundred meters over the course of geologic time relative to today's coastline. So, when the sea level rises significantly, ocean water may submerge large area of continent to form epicontinental seas. And when sea level falls, portion of continental shelves, the relatively shallow part of the ocean adjacent to continents, may be exposed. So therefore, an epicontinental seas or an inland seas is a shallow sea that covers the central areas of continents during the period of high sea level that result in marine transgression, while the continental shelves is the shallow sea floor. Generally, it is less than 200 meter in water depth, which surrounds continents and island. So that is the difference between the epicontinental seas and continental shelves. Okay, then let us proceed to the characteristic of the ocean water. A layer of salt water forms a single global ocean that covers 70.8% of the Earth's surface. And when the Earth first formed, most of the hydrogen atoms that would later compose molecular water existed in hydroxide ions bonded to solid minerals in rock of the crust and mantle. Melting of this rock released by hydroxide, which then bonded to hydrogen to yield water molecules that bundled out of a volcano as a vapor. And during the Earth's early history, the planet remained so hot that this water vapor stayed in the atmosphere. Oceans formed when the planet cooled enough for water vapor to contain the full as liquid water that could collect in ocean basins. While the volume of ocean water has stayed fairly constant for most of geologic time, individual molecules of water do not remain in the ocean for very long, for ocean serves as but one of several reservoirs in the hydrologic cycle. In fact, on average, a given molecule of water remains in liquid form in the ocean for less than 4,000 years before it evaporates to become vapor in the air. Then, within hours to days, the vapor condenses or crystallizes and falls back to the Earth's surface. So, this is the characteristic of ocean water, and it talks about where does the water in the oceans come from. And now, let us proceed to the salt of the sea. So, if I'm going to ask you, I know that all of you here already went in the sea or in the beaches to have picnic and barbecue. So what you've experienced is that every time I went in the sea or in the beaches, of course what you've noticed or what we have experienced is that the taste of the water is salty. And the other thing that we've experienced is that every time we swim, it seems that we float more easily than we do in a fresh water, like river, streams, lakes, and etc. That's because ocean water is a solution containing dissolved salts. In a solution, dissolved ions fit between water molecules without changing the overall volume of the water. So adding salt to water increases the water's density. You float higher in a denser liquid or in the seawater than in a less dense liquid, which is the fresh water. Because according to Archimedes' principle, an object sinks in water only to a depth at which the weight of the water displaced equals to the weight of the whole object. So how salty does the sea get? It has about the same saltiness as a solution. You can prepare by stirring a teaspoon of salt into a cup of a warm water. More precisely, typical seawater contains about 26.5% of water and 3.5% of salt by weight. In contrast, typical fresh water contains less than 0.02% salt. Put another way, seawater contains about 220 times the amount of salt in fresh water. There's so much salt in the sea that if all of its water molecules evaporated, the layer of salt left behind will be about 67 meters or 220 feet thick, the height of a 25-story building. Oceanography refers to the concentration of salt in water as salinity. Salinity refers to the concentration of salt in water, or as a quick definition, it is the level of saltiness, to be more precise, and it is the concentration of dissolved salts in water. So that is salinity. And what is estuaries? Estuaries is a place where seawater floods the mouth of the river, or estuaries are areas where the river meets the sea. And brackish water is when the salty water or seawater mixes with fresh river water, then the result of it is what we call brackish water. So it's basically found in the estuary, which is the place where seawater floods or the seawater and the fresh water meets. Therefore, brackish water has less salinity than the sea water. Brackish water also develops where glacial meltwater enters the sea or where heavy rain falls on the sea surface. And what is halocline? Halocline refers to the gradational boundary between surface water salinities and deep water salinities. So it is the boundary of a salt water, of a seawater rather, and a fresh water. So as what you see on the screen, it is the picture. It is an example of a halocline. So halocline is the boundary. So as what you see, this is a boundary of a seawater and a fresh water. So that's the example of halocline. Okay, let us continue the discussion. So are you aware of what does the salt in the ocean consist of? A chemical analysis rather indicate that the positive ions in seawater include sodium, potassium, calcium, magnesium, chloride, and sulfate. The proportions of different ions stays the same throughout the ocean, and most of the ions are sodium and chloride. So guys, let us proceed to the last part of my discussion. A question that is asking if we can drink the sea. So even myself, I've been thinking of that. And as what I know, drinking seawater is really harmful in our health. And that's according to our medical professionals or health researchers. But there is a process on that. There is something that should be done to drink the sea water. And now we are going to tackle that matter. And you know that a human blood has a salinity of 0.9% by weight. That is much less than that of sea water. Our kidneys regulate the salinity of our blood. So if we drink seawater, our bodies excrete the excess of salt in urine. To keep your blood salinity normal, you would have to excrete more water than you drink. So drinking seawater eventually leads to death by dehydration. That is, of course, if you don't die first in seizure or a heart failure, for excess salt in your blood can disrupt the conduction of electrical signal by nerves. Clearly, we need fresh water to survive. And yeah, what I've said, drinking sea water is really harmful in our health because it may lead us to death. As society's need for fresh water increases, we are using up supplies of natural fish, surface water, and groundwater. Can we take the salt water of seawater to produce fresh water? So that's the question. So definitely yes, we can take the salt out of seawater to produce fresh water. And that can be removed, or salt can be removed from water by desalinization. And how desalinization involves either distillation or reverse osmosis. So, distillation, it is the process of removing salts and minerals from target substance or seawater to become fresh water. So, during distillation, workers pump seawater into a tank and heat the water to accelerate evaporation. When seawater evaporates, it leaves its salt behind. So the resulting vapor consists of fresh water, and condensation of the vapor produces liquid fresh water. Most commercial distillation operations use multi-stage flash distillation. And multi-stage flash distillation, it is a thermal process of desalting relatively large quantities of seawater. And here is the example in the next page. Okay, and as what you see, that is the example of a multi-stage flash distillation. And this picture shown is one of the example in the European country. And as what is stated, it is a multi-stage flash distillation plant on the coast of a desert, produces 470 million of liters and 125 million of gallons of fresh water a day. That is enough to supply a small city. So how about the reverse osmosis? Reverse osmosis is it purifies seawater without heating it. So that is the process in which the desalinization occurs. So reverse osmosis is one of that process in which it purifies seawater without heating it. So that's all for today. That is the end of my reports, and I hope that you understand. So for the continuation of my report, let us lend our ears to the next reporter. And that's all. Thank you.